The third theme is improving workflow systems interface with legacy and emerging HPC software and hardware stacks. That is going to be co-led by Douglas Thain from University of Notre Dame and Rosa Figueira from Heriot-Watt University.
Thank you. Hello, everyone. I'm going to do the first part and Doug is going to do the final one. So in this, basically in this theme, what we are going to talk about is about improving workflow systems interface with legacy and also with emerging HPC software and hardware. So, for example, scientific applications tend to have a much longer lifetime than the workflows and software technologies. For example, I've been working for a long time with seismologists, and one of the things that they have been always doing for the last 10 years is cross correlations. So if you ask me to do a workflow for a cross correlation 10 years ago, I will probably pair the workflow with a software technology, maybe back in the day, Hadoop, or maybe with Apache Storm. Whereas if I do it right now, maybe my workflow technology are going to pair with Apache Flink, or maybe, just to give an idea, or maybe with Dask, or maybe with another technology. So the scientific applications, they are there. They have like a longer life than basically the software. The software appear more often. So one of the reasons is because the hardware capabilities, the things that we have available in HPC. For example, now it's very often that we have GPUs, whereas I don't know, 5 years ago, it was very weird that anyone was having access to GPUs, and now we have also TPUs and so on. And also because we have seen for a while that also scientific communities are moving from HPC, let's say, infrastructures to cloud infrastructures. I don't know, for example, in US, you have Chameleon, whereas in Europe, we have the European Open Science Data Cloud. They also, so these infrastructures, basically, they also bring other type of software ecosystem that at the same time, workflows should be updated to use those as well. So the question that we want to solve is, so we are raising is, can we allow users to describe their computational steps independently of the computer engine or hardware that they're using for running? This touches very much with semantics as well, but as well with the computational steps that are involved and the hardware and the software engines that they're going to use. So we are going to discuss that during the breakout sessions. But if the answer is not, is how we can actually advise them so we can actually help them to transform their workflows to another technologies that they didn't have before. So we need to find like the right balance between the user requirements. Some of them, they have a very specific requirements for running their applications in their local cluster or clouds and also to the long-term workflow requirements. So what is good for the community? And one example is, for example, running containers in HPC clusters. So a couple of years ago, many people started to ask or demand, can we run our Docker containers? And the community say, okay, Docker, no, but containers, yes. So that was a nice way that the community was pushing for. At the beginning, some of them, they were saying Dockers, but at the end, it were other solutions like Singularity that they are provided by the HPC. So the key findings from the previous meeting that aligned to this theme were the following ones. So with the AI workflows, I think that we need to basically give support for heterogeneity of computer resources by managing properly heterogeneous hardware. As I said before, GPUs, CPUs, TPUs, and I don't know, maybe in 3 years are coming more and new hardware. With the theme 4, scale and beyond, scale is challenge and beyond. So as somebody said, and I actually have suffer for this, HPC resources, allocations, policies, and schedulers are not designed in workflows in mind and need more precise control over resources and job behavior. So that is something that the people that develop workflows are always fighting with HPC clusters. Where again, if you go to the cloud community, it's much more easy to install or to run your workflows because you have all the freedom. But we also still want to use HPC resources. From the theme 4 as well, we need the necessary resources descriptions for heterogeneous hardware and currently are not available to the workflow users or systems. From the theme 5, what we were saying is that there are broad differences between workflow systems. Again, so very often developers start to solving a problem and they end up with a new workflow system, which is not great. Again, that could be because suddenly for your application want to use a hardware or a software that you didn't find a workflow system that have a mapping. So you end up doing your own workflow system that maps to that, again, that technology. The final point was in which layer should we focus with interoperability. This goes very well with the theme 2 that Stian just said. Should we, I don't know, go at the application level? Should we go to at the pattern level? Should we go to the DAG or single jobs? So basically that is what we are going to discuss, and I hope you join us to basically attach to do these things.
So I think we presented our results here in a somewhat different form. Broadly speaking, I think our discussion centered around some level of disconnect between HPC operators and users of workflows and workflow developers, in the sense that HPCs are optimized for a rather different use case than grids and clouds. And also that HPCs tend to vary quite a lot in capabilities and assumed usage in ways that are not always made explicit. And so I think there are a lot of stories shared about the frustration of a workflow or a workflow system that works correctly in one environment, but then you take it to another that sort of seems it should be similar, but it doesn't work. So we ended up focusing on two rather focused problems that we think the community can make progress in a rather concrete way. One of these problems is the issue of discovering site capabilities. So when we look at HPCs, there are all sorts of ways that users understand that both sites and machines differ. They have different core counts, they have different memory, they have different quantities of GPUs and types of GPU. Their file systems are mounted in different places and have different consistency semantics. There are different groupings of nodes and racks and machines and constellations and so forth. And at some level, both the user and the workflow system need to understand this in order to operate correctly. And several people said, well, what we do is we go out and reread the documentation and then we change all the details to make it work. And of course, that's not a sustainable approach. So what we would like to see is some standard method of a user or the workflow system to query a site for information about all these details in a machine readable way. I think one way this was expressed is, wouldn't it be nice if there was a /etc/capabilities file that you could query and would tell you about the site? Now, of course, the challenge here is that this doing so would require the facility to invest in this sort of work. And it's hard to convince them to do this. So in working towards a solution here, first we need to do some preliminary work. There have been a variety of systems that have explored site reporting and capabilities, things like Glue in EGI, the Globus MDS from the grid days, OSG, all have solutions. And we think we need to do some legwork to understand how these systems worked and what sort of experience was learned from them. We think we need some sort of summit between tool developers and facility operators to articulate the problem better and understand the space of possible solutions. And we thought a very doable outcome would be, instead of putting the burden on facility operators to do this for us, to instead collect in one place a reasonable quantity of an essential set of machine readable information that describes some widely used facilities. So we imagine, as sort of a first blush, that this would be a big JSON document in GitHub. And if this accurately described the essential properties of, say, 5 sites, then we could prototype some workflow systems querying these capabilities and then acting on them. And then iteratively develop both the contents of this file as well as the schema and expectations. Now, if this process works, we think a sign of success would be that the facilities, as well as the users and the tool developers, start making contributions to this body of knowledge so that it grows in value and becomes a community resource. Now, of course, a big question for anything like this is really who owns it and who has responsibility for it. And it's sort of easy to say, well, everybody's going to contribute to it. But if everybody has responsibility, then nobody has responsibility. So really long term, who owns this? Is it the users, the tool developers, the facilities? And I think that's kind of an open question. And I'm seeing lots of comments flying by saying we should look at a bunch of related systems, and I'm very glad to see that. So we'll add that to the list of things to survey. The other concrete problem that we discussed is matters of authentication. And this one is a little harder to describe because it's not quite so clear where the locus of either the problem or the solution is. But it comes down to this. Until very recently, access to HPCs was gated by SSH passwords and keys. And so if you wanted to build a system that would interact with an HPC in an automated way, you could build it around SSH. Anytime you want to take an action, you SSH in and do it. And of course, this has changed with the introduction of two-factor authentication that requires when you SSH in, then to answer a question on your cell phone in order to proceed. And this presents a barrier to a workflow management system, or really to any piece of software that needs to interact with an HPC in an automated manner. This comes up in science gateways and cron jobs and data transfer and all sorts of things. So really this is a generalized problem of how do we get automated components to authenticate to HPCs in order to do bulk work. And the solution can't possibly be that the user's cell phone goes off every 30 seconds and they have to type a number in. Now, some questions that came up were, well, is this really a workflow management system problem? And I don't think it's solely a workflow management system problem, but certainly the workflow management systems have to interface with it in some way. Now, again, there are a variety of technologies out there. So there's Globus authentication, there is PSI tokens, there's this whole space of OAuth and web tokens that operates in the space of delegating the capability to authenticate. And it may be that one or more of these technologies can be applied to the solution. It may be that none of them quite fits the use case. So there's some legwork to be done to understand how these things fit in and how well they could work. But nonetheless, it is not the case that any of these things are deployed across HPCs or universally used by workflow management systems. So even if the solution is staring us in the face, there is still both technical and social work to select and move forward with a solution. Now, this is more complicated. Again, we need a summit of some kind, but here this involves tool developers, yes, facility operators, yes, but also needs a strong helping of end users and the auth technology providers. Because if we put something together that's too complicated to figure out, users aren't going to use it. And so it needs to have a strong component of user experience. Now here we were a little less ambitious about the outcomes. There are a number of next generation systems currently in the planning stages, and it was proposed that a great outcome would simply be to understand the problem and make sure that the requirements of workflow systems get written into the design and procurement documents for the next generation of systems. A more technical outcome could be that we identify a site that is particularly cooperative and willing to deploy or test some new technologies here, and show one or more workflow systems that are able to use a particular site in this way, and use that as an exemplar for further development. Again, I think a large portion of this is social coordination as much as it is technology. Part of this is the HPCs coming around to see the needs of workflow systems, and also workflow systems coming around to see the security concerns that are driving HPCs doing this. So those are the two community activities that we proposed. And if you desire to see all the notes and whatnot in the earlier discussion, then that's farther down the document.